Hello there. Tonight, we're going to explore something extraordinary, something that sits at the very edge of what science understands about being human. We're going to examine the mysterious boundary between mind and matter, between thought and flesh, between consciousness and the physical world it somehow inhabits and influences. For centuries, philosophers debated whether the mind could truly affect the body, whether thoughts were merely ephemeral shadows cast by brain chemistry or something more, something with genuine power to reshape the material world. Modern neuroscience has begun to answer these ancient questions, and the answers are more remarkable than anyone imagined. Your thoughts can change the structure of your brain. Your beliefs can alter your body's chemistry. Your mental practices can influence the very aging of your cells. The placebo effect is real, measurable, powerful. Meditation physically rewires neural pathways. Visualization activates the same brain regions as actual physical practice. The mind is not separate from matter, but deeply, intimately entangled with it, shaping and being shaped in an endless dance of mutual influence. Tonight, we'll explore 100 facts about this profound connection, about neuroplasticity, the placebo effect, biofeedback, and the quiet power of consciousness to transform the physical reality of your body and brain. So settle in, let your breathing slow, and prepare to discover the extraordinary capabilities hidden within your own mind. The mind-body connection is not a metaphor, but a biological reality, mediated by complex networks of neurons, hormones, and immune signals that constantly communicate between brain and body. When you experience an emotion, it's not confined to your mind. It cascades through your entire physiology. Fear triggers the release of cortisol and adrenaline, preparing your body for fight or flight. Joy releases endorphins and dopamine, creating physical sensations of pleasure and well-being. Chronic stress doesn't just feel bad. It suppresses immune function, increases inflammation, and accelerates cellular aging. The brain and body are not separate systems, but a unified whole, constantly influencing each other through bidirectional pathways. The vagus nerve, wandering from brainstem to abdomen, carries signals in both directions, allowing gut feelings to influence thoughts, and thoughts to influence digestion. The immune system communicates with the brain through cytokines, inflammatory molecules that can trigger sickness behavior, the fatigue and withdrawal you feel when fighting infection. Understanding this deep integration helps explain how mental states can have such profound physical effects, how meditation can reduce inflammation, how stress can trigger illness, how positive emotions can enhance healing. The mind-body connection is not mystical but mechanical, rooted in the intricate biology of human physiology. The discovery of neuroplasticity revolutionized our understanding of the brain, revealing that neural structure is not fixed but constantly changing in response to experience. For most of the 20th century, neuroscientists believed that the adult brain was essentially static, that you were born with a certain number of neurons and connections that could only decline with age. This view has been completely overturned. We now know that the brain remains plastic throughout life, capable of forming new connections, strengthening existing ones, and even generating new neurons in certain regions. Every experience you have, every thought you think, every skill you practice, physically changes your brain. London taxi drivers who must memorize the city's complex street layout develop enlarged hippocampi, the brain region involved in spatial navigation. Musicians who practice intensively show expanded motor cortex regions, controlling their fingers. People who learn to juggle show increased gray matter in visual and motor areas. These changes are not subtle, they're visible on brain scans, measurable and real. Neuroplasticity means that your brain is not a fixed machine but a living, adapting organ that reshapes itself based on how you use it. This has profound implications for learning, recovery from injury, mental health treatment, and the possibility of deliberate self-transformation through mental practice. The concept of embodied cognition challenges the traditional view that thinking happens only in the brain, suggesting instead that the body plays an active role in shaping thought. Your physical state influences your mental state in ways both obvious and subtle. Standing in a powerful pose, chest open and shoulders back, increases testosterone and decreases cortisol, making you feel more confident. Smiling, even when forced, activates neural pathways associated with happiness, actually improving mood. The temperature of a drink you're holding affects your perception of others. Warm drinks make people seem warmer and more trustworthy. Physical cleanliness influences moral judgment. People who wash their hands feel less guilty about past transgressions. These effects reveal that cognition is not purely abstract, but deeply rooted in bodily experience. The brain uses the body as a tool for thinking, grounding abstract concepts in physical sensations and actions. This embodied nature of cognition helps explain why physical practices like yoga and Tai Chi can have such profound effects on mental state, why movement can enhance creativity, why changing your posture can change your mood. The mind doesn't just inhabit the body, it thinks through the body, using physical states as scaffolding for mental processes. The autonomic nervous system, which controls involuntary functions like heart rate, breathing, and digestion, was long thought to be beyond conscious control. This assumption has been challenged by research on biofeedback and meditation, which demonstrate that people can learn to influence these supposedly automatic processes. Biofeedback training uses real-time monitoring of physiological signals, heart rate, skin temperature, muscle tension, to teach conscious control of autonomic functions. People can learn to slow their heart rate, warm their hands by increasing blood flow, relax specific muscle groups. This isn't magic but skill acquisition, learning to recognize and influence subtle bodily states that normally operate below conscious awareness. Meditation practices, particularly those focused on breath and body awareness, also develop this capacity for autonomic influence. Experienced meditators can significantly slow their metabolism, reduce oxygen consumption, and alter brainwave patterns in ways that were once thought impossible. These abilities demonstrate that the boundary between voluntary and involuntary is more permeable than previously believed, that conscious intention can reach into the autonomic realm and exert genuine influence. This has important implications for health, suggesting that mental training could help manage conditions like hypertension, chronic pain, and anxiety that involve autonomic dysfunction. The stress response, while essential for survival, becomes harmful when chronically activated, illustrating how mental states can damage physical health. When you perceive a threat, real or imagined, your hypothalamus triggers a cascade of hormonal changes. The pituitary gland releases ACTH, which signals the adrenal glands to produce cortisol and adrenaline. These stress hormones prepare your body for immediate action, increasing heart rate, blood pressure, and blood sugar, while suppressing non-essential functions like digestion and immune response. This response is adaptive for acute threats, helping you escape danger or fight attackers. But modern stressors, work deadlines, financial worries, relationship conflicts, don't require physical action and don't resolve quickly. When the stress response is activated chronically, it becomes toxic. Elevated cortisol suppresses immune function, making you more susceptible to infection and slowing wound healing. It promotes inflammation, contributing to cardiovascular disease, diabetes, and autoimmune conditions. It damages the hippocampus, impairing memory and learning. Chronic stress literally changes brain structure, shrinking the prefrontal cortex while enlarging the amygdala, making you more reactive and less able to regulate emotions. Understanding the stress response helps explain how psychological factors can have such profound health effects, and why stress management is not just about feeling better, but about preventing serious physical illness. The relaxation response, discovered by Herbert Benson, is a physiological state opposite to the stress response, characterized by decreased metabolism, heart rate, blood pressure, and breathing rate. Benson found that this state could be reliably induced through simple meditation techniques involving focused attention and passive disregard of distracting thoughts. When you elicit the relaxation response, your body shifts from sympathetic to parasympathetic nervous system dominance, from fight or flight to rest and digest. This shift has measurable physiological effects. Oxygen consumption decreases, sometimes dramatically. Heart rate and blood pressure drop. Muscle tension decreases. Brain waves shift from beta to alpha patterns, associated with calm alertness. Gene expression changes, with genes involved in inflammation and stress response being downregulated, while genes involved in immune function and cellular metabolism are upregulated. These changes are not just subjective feelings of calm, but objective, measurable alterations in physiology. Regular elicitation of the relaxation response has been shown to help manage hypertension, chronic pain, anxiety, insomnia, and other stress-related conditions. The relaxation response demonstrates that just as negative mental states can harm the body, positive mental states can heal it. That the mind's influence on matter flows in both directions, capable of both damage and repair. Psychoneuroimmunology is the field studying how psychological factors influence the immune system, revealing intricate connections between mind and immunity. The immune system was once thought to operate independently of the nervous system, but we now know they're intimately connected. Immune cells have receptors for neurotransmitters and hormones, allowing them to respond to signals from the brain. The brain, in turn, monitors immune activity through cytokines and other immune signals. This bidirectional communication means that mental states can directly influence immune function. Chronic stress suppresses immunity, reducing the activity of natural killer cells that fight viruses and cancer, decreasing antibody production, and slowing wound healing. Depression is associated with increased inflammation, elevated levels of pro-inflammatory cytokines that contribute to the symptoms of depression and may help explain the link between depression and cardiovascular disease. Conversely, positive mental states can enhance immunity. People who practice meditation show increased antibody response to vaccines. Social connection and positive emotions are associated with better immune function and faster recovery from illness. The mechanisms involve stress hormones, autonomic nervous system activity, and direct neural connections to immune organs like the thymus and spleen. Psychoneuroimmunology provides a scientific framework for understanding how mental and emotional states can influence susceptibility to illness and capacity for healing. The concept of allostatic load describes the cumulative wear and tear on the body from chronic stress and repeated activation of stress response systems. Allostasis is the process of maintaining stability through change, the constant adjustments your body makes to meet environmental demands. When these demands are chronic or excessive, the cost of adaptation accumulates, creating allostatic load. High allostatic load is associated with numerous health problems: cardiovascular disease, diabetes, cognitive decline, weakened immunity. It's measured through biomarkers including cortisol levels, blood pressure, cholesterol, inflammatory markers, and waist-hip ratio. People with high allostatic load show accelerated aging and increased mortality risk. Importantly, allostatic load is influenced not just by objective stressors, but by how you perceive and respond to stress. Two people facing similar life challenges may have very different allostatic loads depending on their coping strategies, social support, and mental resilience. This means that psychological interventions, stress management, cognitive reframing, social connection can reduce allostatic load and its health consequences. The concept of allostatic load provides a bridge between psychological stress and physical disease, explaining how chronic mental strain translates into bodily damage and why mind-body interventions can have genuine health benefits. The gut-brain axis represents another crucial pathway of mind-body communication, with the gut microbiome influencing brain function and mental state. Your digestive system contains hundreds of millions of neurons, sometimes called the enteric nervous system, or second brain, that communicate constantly with your central nervous system. The gut microbiome, the trillions of bacteria living in your intestines, produces neurotransmitters including serotonin, dopamine, and GABA that influence mood and cognition. About 90% of the body's serotonin is produced in the gut, not the brain. The gut microbiome communicates with the brain through multiple pathways: the vagus nerve, immune signals, and metabolites that cross the blood-brain barrier. Disruption of the gut microbiome has been linked to depression, anxiety, autism, and neurodegenerative diseases. Conversely, stress and emotions affect gut function, explaining why anxiety causes stomach upset and why chronic stress can trigger digestive disorders. The gut-brain axis reveals that mental health is not purely a brain phenomenon, but involves the entire body, that what you eat affects not just your physical health, but your mental state, and that interventions targeting the gut, probiotics, diet changes, may help treat mental health conditions. This bidirectional communication between gut and brain is another example of how deeply mind and body are integrated. Heart rate variability, the variation in time intervals between heartbeats, is an important indicator of autonomic nervous system balance and overall health. A healthy heart doesn't beat like a metronome, but varies its rhythm in response to breathing, physical activity, and mental state. High heart rate variability indicates good autonomic flexibility, the ability to shift smoothly between sympathetic and parasympathetic states. Low heart rate variability is associated with chronic stress, anxiety, depression, and increased risk of cardiovascular disease and mortality. Heart rate variability can be influenced by mental practices. Slow, deep breathing increases heart rate variability by enhancing parasympathetic tone. Meditation and relaxation practices improve heart rate variability over time. Even brief practices, like taking a few slow breaths, can shift autonomic balance toward parasympathetic dominance. Biofeedback training using heart rate variability helps people learn to regulate their autonomic state, improving stress resilience and emotional regulation. The fact that a simple mental practice like slow breathing can measurably alter heart rate variability demonstrates the direct influence of mind on body, showing that conscious intention can reach into the autonomic nervous system and create beneficial physiological changes. Heart rate variability provides a window into autonomic function and a target for mind-body interventions. The phenomenon of emotional contagion demonstrates how mental states can spread between people through unconscious mimicry and physiological synchronization. When you interact with someone, you automatically mimic their facial expressions, posture, and vocal patterns. This mimicry triggers corresponding emotions in you through a process called facial feedback. Your brain interprets your own expressions and generates matching feelings. If someone smiles at you, you unconsciously smile back, and this smile makes you feel happier. If someone looks anxious, you mirror their tension, and this makes you feel anxious. Emotional contagion happens rapidly and unconsciously, operating below conscious awareness. It's mediated by mirror neurons, brain cells that fire both when you perform an action and when you observe someone else performing it. Emotional contagion has important implications for social interaction and mental health. Being around stressed, anxious people can make you stressed and anxious. Being around calm, positive people can improve your mood and reduce stress. This is why social environment is so important for mental health, why supportive relationships are protective, and why isolation can be harmful. Emotional contagion also demonstrates that mental states are not purely individual, but social, that minds influence each other through bodily channels, creating shared emotional atmospheres that affect everyone present. The concept of interoception, the perception of internal bodily states, is crucial for emotional awareness and self-regulation. Interoception involves sensing signals from inside your body: heartbeat, breathing, hunger, pain, temperature, muscle tension, gut feelings. The insula, a brain region deep within the cortex, integrates these signals into conscious awareness. People vary in interoceptive accuracy, how well they can perceive their internal states. High interoceptive accuracy is associated with better emotional awareness, the ability to recognize and label your feelings. It's also associated with better self-regulation, the ability to manage emotions and respond appropriately to stress. Conversely, poor interoception is linked to alexithymia, difficulty identifying and describing emotions, and to various mental health conditions including anxiety, depression, and eating disorders. Interoception can be enhanced through practices that direct attention to bodily sensations, body scan meditation, yoga, mindful breathing. Improving interoception can enhance emotional intelligence and stress resilience. The importance of interoception reveals that emotions are not just mental events but embodied experiences, that feeling your feelings requires sensing your body, and that mind-body awareness is essential for psychological health. Interoception is the channel through which body speaks to mind, providing the raw data that becomes emotional experience. The default mode network is a set of brain regions that activate when you're not focused on the external world, during rest, daydreaming, and self-reflection. This network includes the medial prefrontal cortex, posterior cingulate cortex, and parts of the parietal and temporal lobes. The default mode network is involved in autobiographical memory, imagining the future, thinking about others' mental states, and constructing the narrative self. It's most active when your mind wanders, when you're thinking about yourself, your past, your future, your relationships. Interestingly, overactivity of the default mode network is associated with rumination, depression, and anxiety. People who ruminate excessively show hyperconnectivity within the default mode network. Meditation practices, particularly focused attention meditation, reduce default mode network activity, quieting the constant self-referential chatter of the mind. Experienced meditators show decreased default mode network activity even during rest, suggesting lasting changes in how the brain operates. The default mode network reveals that the resting brain is not inactive, but engaged in self-focused thought and that this self-focus can become problematic when excessive. Mind-body practices that quiet the default mode network may help break cycles of rumination and worry, providing relief from the tyranny of self-focused thought. The placebo effect is one of the most powerful demonstrations of mind over matter, showing that belief alone can produce measurable physiological changes. A placebo is an inert substance or sham treatment that has no direct therapeutic effect. Yet when people believe they're receiving real treatment, they often experience genuine improvement. This isn't just subjective feeling better. Placebo responses involve real biological changes. Brain imaging shows that placebo painkillers activate the same pain relief pathways as actual opioids, releasing endogenous opioids in the brain. Placebo treatments for Parkinson's disease trigger dopamine release in the striatum, the same response produced by actual Parkinson's medications. Placebo antidepressants alter brain activity in regions involved in mood regulation. The magnitude of placebo effects can be substantial. In some studies, placebos produce improvement in 30 to 60% of patients, sometimes rivaling the effects of active treatments. The placebo effect reveals that expectation and belief are not just psychological phenomena, but biological forces that can activate healing mechanisms. Understanding the placebo effect doesn't diminish its importance, but highlights the remarkable capacity of the mind to influence bodily processes, suggesting that harnessing this capacity could enhance medical treatment and promote healing. The nocebo effect is the dark mirror of the placebo effect, demonstrating that negative expectations can cause harm. When people expect negative outcomes, they often experience them even when receiving inert substances. If you're told a pill will cause nausea, you're more likely to feel nauseous, even if the pill is sugar. If you're warned about side effects, you're more likely to experience them. The nocebo effect can be powerful and disturbing. In clinical trials, people receiving placebos often report side effects matching those of the active drug simply because they were warned about them. People who believe they're sensitive to electromagnetic fields report symptoms when exposed to sham signals, even though controlled studies show no physiological basis for electromagnetic hypersensitivity. The nocebo effect reveals that negative beliefs and expectations can create genuine suffering, that fear and anxiety can manifest as physical symptoms. This has important implications for medical communication. How doctors discuss risks and side effects can influence whether patients experience them. It also highlights the importance of managing expectations and beliefs, not through deception but through balanced, hopeful framing that doesn't amplify fears. The nocebo effect shows that mind over matter works in both directions, that thoughts can harm as well as heal. Conditioning plays a crucial role in placebo and nocebo effects, with learned associations between cues and outcomes creating automatic physiological responses. If you repeatedly pair a neutral stimulus, like a colored pill, with an active drug that produces specific effects, eventually the neutral stimulus alone will trigger those effects. This is classical conditioning, the same process Pavlov demonstrated with dogs, salivating to bells. In humans, conditioning can create powerful placebo responses. Cancer patients who receive chemotherapy often develop conditioned nausea, feeling sick when they enter the treatment room or see the nurse before any drugs are administered. This conditioned response can be harnessed therapeutically. Researchers have used conditioning to reduce the dose of immunosuppressant drugs needed after organ transplant drugs, pairing the drug with a distinctive taste, then occasionally substituting placebo with the same taste, which triggers partial immunosuppression through conditioning. Conditioning reveals that placebo effects aren't just about conscious belief, but involve deeper automatic learning processes. Your body learns to respond to cues associated with healing or harm, and these learned responses can be powerful and persistent. Understanding the role of conditioning in placebo effects suggests ways to enhance therapeutic outcomes through careful attention to treatment context and cues. The ritual and context of medical treatment contribute significantly to placebo effects, with factors like provider warmth, treatment complexity, and cultural meaning all influencing outcomes. Placebo effects are stronger when treatments are delivered with confidence and warmth, when the provider believes in the treatment and communicates that belief. They're stronger for invasive procedures than pills. Sham surgery produces larger placebo effects than sham medication. They're stronger when treatments are expensive, complex, or technologically sophisticated. They're influenced by color. Red pills are better stimulants, blue pills are better sedatives. Brand-name medications produce larger placebo effects than generic versions of the same drug. These contextual factors work through multiple pathways, shaping expectations, activating conditioning, and creating meaning. The ritual of treatment, the white coat, the medical setting, the solemn consultation, all prime the brain for healing. This doesn't mean medicine is just theater, but it does mean that how treatment is delivered matters as much as what treatment is delivered. Understanding contextual factors in placebo effects can help optimize medical care, ensuring that the healing ritual supports rather than undermines the biological effects of treatment. It also suggests that complementary and alternative medicine practices may derive some of their benefit from rich ritual and meaning, even when their specific mechanisms are questionable. Placebo analgesia, pain relief from inert treatments, is one of the most studied placebo effects and reveals sophisticated brain mechanisms underlying mind over matter. When you expect pain relief, your brain releases endogenous opioids, natural painkillers that bind to the same receptors as morphine. This release can be blocked by naloxone, an opioid antagonist, proving that placebo analgesia involves real opioid activity, not just changed perception. Brain imaging shows that placebo analgesia reduces activity in pain processing regions, including the anterior cingulate cortex and insula. It also activates the prefrontal cortex and periaqueductal gray, regions involved in pain modulation. Interestingly, placebo analgesia can work even when people know they're receiving a placebo, as long as they understand that placebos can be effective. This open-label placebo effect suggests that conscious belief in the mechanism, rather than deception, may be sufficient to trigger pain relief. Placebo analgesia demonstrates that pain is not simply a direct readout of tissue damage, but a complex experience shaped by expectation, attention, and meaning. The brain has powerful pain modulation systems that can be activated by belief and expectation, providing genuine relief without drugs. Understanding placebo analgesia could help develop psychological techniques for pain management that harness the brain's natural analgesic systems. The neurobiology of placebo effects involves multiple brain systems, including reward pathways, prefrontal cortex, and neurotransmitter systems. Expectation of benefit activates the brain's reward system, particularly the ventral striatum and ventromedial prefrontal cortex, regions involved in processing anticipated rewards. This activation triggers release of dopamine, a neurotransmitter involved in motivation and pleasure. In Parkinson's disease, where dopamine neurons are depleted, placebo treatments can trigger substantial dopamine release in the striatum, temporarily alleviating symptoms. The prefrontal cortex, involved in expectation and cognitive control, modulates activity in regions producing placebo responses. Connectivity between prefrontal cortex and pain processing regions predicts the magnitude of placebo analgesia. Different neurotransmitter systems are involved in different placebo effects. Opioids for pain relief, dopamine for motor symptoms and reward, cannabinoids for certain types of pain. The neurobiology of placebo effects reveals that they're not imaginary or purely psychological, but involve real changes in brain chemistry and activity. These changes are triggered by expectation and belief, demonstrating that mental states can directly influence neurotransmitter release and neural activity. Understanding the neurobiology of placebo effects provides insight into how mind influences brain and how this influence could be harnessed therapeutically. Individual differences in placebo responsiveness reveal that some people show larger placebo effects than others, and these differences are associated with personality traits and brain characteristics. People high in optimism, suggestibility, and openness to experience tend to show larger placebo responses. People with certain genetic variants, particularly in genes affecting dopamine and opioid systems, show different placebo responsiveness. Brain imaging reveals that placebo responders have different patterns of brain activity and connectivity than non-responders. Placebo responders show stronger connectivity between prefrontal cortex and regions involved in pain processing or symptom generation. They show greater activation of reward pathways in response to treatment cues. These individual differences suggest that placebo responsiveness is a stable trait, at least partly determined by genetics and brain structure. This has important implications for personalized medicine. It may be possible to predict who will respond well to placebo components of treatment and tailor approaches accordingly. It also suggests that placebo responsiveness could potentially be enhanced through training by strengthening the brain networks involved in expectation and reward processing. Understanding individual differences in placebo effects helps explain why some people benefit greatly from treatments with large placebo components while others don't, and why medical responses are so variable across individuals. The ethics of placebo use in medicine is complex, balancing the potential benefits of harnessing placebo effects against the importance of informed consent and honest communication. Traditionally, placebos were sometimes used deceptively. Doctors prescribed sugar pills while telling patients they were receiving real medication. This practice is now considered unethical because it violates informed consent and undermines trust. However, the discovery that open-label placebos can be effective, that people can benefit from placebos, even when they know they're placebos, suggests a way to harness placebo effects ethically. Doctors can honestly explain that placebos often produce real benefits through mind-body mechanisms and offer them as a treatment option. This preserves autonomy and honesty while potentially providing benefit. Another ethical approach is to optimize the placebo components of all treatments, the ritual, context, and communication without deception. Every medical treatment has placebo components, and enhancing these through warm, confident, hopeful communication and careful attention to treatment context can boost out compromising ethics. The ethics of placebo use highlights the tension between maximizing benefit and respecting autonomy, but also suggests that this tension can be resolved through honest communication about mind-body mechanisms and careful attention to how treatments are delivered. Placebo effects in depression treatment are particularly large and controversial, with some studies showing that antidepressants are only marginally more effective than placebos. Meta-analyses of antidepressant trials reveal that placebo response rates are often 40 to 50%, while drug response rates are 50 to 60%, a difference that, while statistically significant, is smaller than many people assume. This has led to debates about whether antidepressants work primarily through placebo mechanisms. However, the situation is more complex. Placebo effects in depression may be particularly large because depression involves disrupted reward processing and negative expectations, both of which are directly targeted by placebo mechanisms. The hope and expectation generated by entering treatment may activate reward pathways and shift negative expectations, producing genuine symptom relief. This doesn't mean antidepressants are useless, but it does suggest that their benefits may come partly from placebo mechanisms and partly from specific pharmacological effects. It also suggests that enhancing placebo components of depression treatment through supportive therapy, hopeful communication, and attention to treatment context could boost outcomes. The large placebo effects in depression highlight how powerfully mental states, hope, expectation, belief in treatment can influence mood and emotional functioning, demonstrating mind over matter in the realm of mental health. The placebo effect in surgery is particularly striking, with sham surgeries sometimes producing benefits comparable to real procedures. In a famous study of arthroscopic knee surgery for osteoarthritis, patients who received sham surgery, just incisions without the actual procedure, improved as much as those who received real surgery. Similar findings have emerged for other procedures, including vertebroplasty for spinal fractures and internal mammary artery ligation for angina. These findings are controversial and disturbing, suggesting that some surgical procedures may work primarily through placebo mechanisms. The magnitude of surgical placebo effects likely reflects the power of the surgical ritual. The drama, invasiveness, and cultural authority of surgery create strong expectations of benefit. Surgical placebo effects raise important questions about which procedures are truly necessary and effective versus which work primarily through placebo mechanisms. They also highlight the importance of rigorous testing, including sham surgery controls when ethically feasible, to distinguish real from placebo effects. The surgical placebo effect demonstrates that even invasive physical interventions can work partly through mind-body mechanisms, that the meaning and expectations surrounding treatment can be as important as the physical intervention itself. Placebo effects can persist over time and even grow stronger with repeated exposure, suggesting that they involve learning and conditioning rather than just temporary belief. In chronic pain conditions, placebo effects can last for weeks or months after treatment ends. In Parkinson's disease, placebo responses can be sustained and even increase with repeated placebo administration. This persistence likely reflects conditioning, as repeated pairing of treatment cues with symptom relief strengthens the association, making the cues alone more effective at triggering relief. The persistence of placebo effects has important implications for treatment. It suggests that placebo components of treatment aren't just temporary psychological boosts, but can create lasting changes in how the brain responds to symptoms. It also suggests that carefully designed treatment protocols that optimize conditioning through consistent cues, contexts, and rituals could create more durable placebo effects. The persistence of placebo effects challenges the notion that they're merely temporary or superficial, demonstrating that mind-body mechanisms can create lasting changes in physiology and symptom experience. Understanding how to create and sustain placebo effects could help develop more effective treatments that harness the brain's natural healing capacities. The placebo effect in immune function demonstrates that mental states can influence one of the body's most fundamental defense systems. Studies using conditioning have shown that immune responses can be shaped by expectation and learning. In one classic study, rats were given a drug that suppressed immune function along with saccharin-flavored water. After several pairings, the saccharin water alone began to suppression. Similar conditioning has been demonstrated in humans. People can learn to suppress or enhance immune responses through conditioning, with implications for autoimmune diseases and transplant rejection. Beyond conditioning, stress and mental state directly affect immune function through hormonal and neural pathways. Chronic stress suppresses immunity, while positive emotions and relaxation enhance it. The placebo effect in immune function reveals that the immune system, while often thought of as autonomous, is actually under significant influence from the brain and mental state. This mind-immune connection suggests that psychological interventions could help manage immune-related conditions, that managing stress, cultivating positive emotions, and harnessing placebo mechanisms could boost immune function and improve health outcomes. The immune placebo effect is a powerful demonstration of how deeply mind and body are integrated, how mental states reach into the cellular machinery of immunity. The role of meaning and narrative in placebo effects highlights that healing is not just biological but existential, involving the stories we tell about illness and treatment. When treatment is embedded in a meaningful narrative, when it makes sense within your understanding of illness and healing, it's more likely to produce placebo effects. This is why culturally congruent treatments, those that fit with your cultural beliefs and expectations, often work better than foreign treatments, even when the specific mechanisms are similar. Traditional healing practices may derive much of their effectiveness from providing meaningful narratives that make sense of suffering and offer hope for recovery. The meaning response, as some researchers call it, emphasizes that what matters is not just the physical treatment, but the meaning it carries, the hope it offers, the story it tells about your illness and recovery. This perspective suggests that effective healing requires attention to meaning and narrative, not just biological mechanisms. Doctors who help patients construct hopeful, empowering narratives about their illness and treatment may enhance outcomes through placebo mechanisms. The role of meaning in placebo effects reveals that humans are not just biological organisms, but meaning-making beings, and that healing must address the need for meaning as well as the need for biological repair. Neuroplasticity operates through multiple mechanisms at different scales, from molecular changes at synapses to large-scale reorganization of cortical maps. At the smallest scale, synaptic plasticity involves changes in the strength of connections between neurons. Long-term potentiation strengthens synapses that are repeatedly activated together, following the principle that neurons that fire together wire together. Long-term depression weakens synapses that are rarely used, pruning unnecessary connections. At a larger scale, structural plasticity involves physical changes in neural architecture, growth of new dendritic spines, formation of new synapses, even generation of new neurons in certain brain regions. At the largest scale, cortical reorganization involves remapping of brain regions, with areas taking on new functions in response to experience or injury. All these mechanisms work together to make the brain adaptable. When you learn a new skill, synaptic plasticity strengthens the relevant neural circuits. With continued practice, structural changes consolidate these circuits. If brain regions are damaged, cortical reorganization allows other regions to compensate. Understanding the mechanisms of neuroplasticity reveals that brain change is not a single process, but a cascade of changes at multiple levels, all working to adapt the brain to experience and challenge. Critical periods are windows of heightened plasticity during development when the brain is especially sensitive to experience. The visual system has a well-studied critical period in early childhood, when normal visual input is essential for proper development. Children born with cataracts who don't receive treatment within the first few years may never develop normal vision, even after the cataracts are removed, because the critical period has closed. Similar critical periods exist for language, with children who aren't exposed to language before puberty struggling to achieve native fluency. Critical periods reflect a developmental program where the brain is primed to learn certain things at certain times. During critical periods, plasticity mechanisms are enhanced, making learning easier and more permanent. After critical periods close, plasticity decreases but doesn't disappear entirely. The adult brain remains plastic, but learning requires more effort and may be less complete. Understanding critical periods has important implications for education and intervention, suggesting that certain skills and experiences are best acquired during specific developmental windows. It also highlights that early experience has outsized influence on brain development, that what happens during critical periods can shape the brain for life. Experience-dependent plasticity describes how the brain changes in response to specific experiences, creating neural representations of what you learn and practice. Every skill you acquire, every memory you form, every habit you develop involves experience-dependent plasticity. When you learn to play piano, the motor cortex regions controlling your fingers expand and reorganize. When you learn to navigate a new city, your hippocampus forms new spatial representations. When you learn a second language areas of your brain develop new neural circuits for the new language. Experience-dependent plasticity is activity-dependent. The neural circuits that are most active are the ones that change. This means that what you practice, what you pay attention to, what you repeatedly experience literally shapes your brain. The brain becomes optimized for what you do most often, which can be beneficial or harmful. If you practice skills, your brain becomes better at those skills. If you ruminate on negative thoughts, your brain becomes better at rumination. Understanding experience-dependent plasticity highlights the importance of choosing your experiences and practices carefully, recognizing that you're not just filling time but sculpting your brain, creating neural patterns that will persist and influence future thoughts and behaviors. Neuroplasticity after brain injury demonstrates the brain's remarkable capacity for recovery and compensation, though this capacity has limits. After stroke, the brain can reorganize to compensate for damaged areas. Undamaged regions can take over functions previously performed by damaged areas. New neural pathways can form to bypass damaged tissue. The degree of recovery depends on many factors, including the size and location of the injury, the age of the patient, and the intensity of rehabilitation. Rehabilitation works by harnessing neuroplasticity, using intensive repetitive practice to drive brain reorganization. Constraint-induced movement therapy for stroke patients forces use of the affected limb, preventing compensation with the unaffected limb and driving plasticity in motor areas. This therapy can produce substantial recovery even years after stroke, challenging the old assumption that recovery only occurs in the first few months. However, recovery is rarely complete, and some functions may be permanently lost. Understanding neuroplasticity after injury provides hope for recovery, while also recognizing limits. It suggests that intensive, targeted rehabilitation can drive meaningful recovery by harnessing the brain's plastic capacity, but it also acknowledges that the brain's ability to reorganize, while remarkable, is not unlimited. The concept of maladaptive plasticity describes how the brain's plastic capacity can sometimes create problems rather than solving them. Chronic pain provides a clear example. After injury, pain pathways become sensitized. with neurons becoming more responsive to pain signals. This sensitization can persist long after the injury heals, creating chronic pain without ongoing tissue damage. The pain is real, generated by changes in the nervous system, but it no longer serves a protective function. Phantom limb pain, where amputees feel pain in missing limbs, reflects maladaptive reorganization of somatosensory cortex. Tinnitus, persistent ringing in the ears, often results from maladaptive plasticity in auditory pathways following hearing loss. Addiction involves maladaptive plasticity in reward circuits, with drug use creating lasting changes that make the brain hypersensitive to drug cues and less responsive to natural rewards. Understanding maladaptive plasticity helps explain how the same mechanisms that enable learning and recovery can also create persistent problems. It also suggests that interventions targeting plasticity through training, medication, or brain stimulation might reverse maladaptive changes and restore normal function. Maladaptive plasticity reveals that the brain's flexibility is a double-edged sword, capable of both beneficial adaptation and harmful change. Cognitive training can drive neuroplasticity and improve mental function, though the extent and specificity of these improvements is debated. Working memory training, which involves practicing tasks that challenge your ability to hold and manipulate information, can improve working memory performance and produce changes in brain activity and structure. Attention training can enhance attentional control and reduce distractibility. Cognitive training for older adults can improve memory and processing speed, potentially delaying cognitive decline. However, the benefits of cognitive training are often specific to the trained tasks, with limited transfer to untrained abilities or real-world function. Brain training games may make you better at those specific games without improving general cognitive ability. The key to effective cognitive training appears to be challenge and engagement. Tasks must be difficult enough to push your limits, and you must be motivated and engaged. Understanding cognitive training and neuroplasticity suggests that mental exercise can improve brain function, but not in the simple way that physical exercise improves physical fitness. The brain is more specific, improving primarily in the exact functions you practice. This means cognitive training must be carefully designed to target the abilities you want to improve, and expectations should be realistic about transfer to other domains. Physical exercise is one of the most powerful drivers of neuroplasticity, with effects extending far beyond the motor system. Aerobic exercise increases production of brain-derived neurotrophic factor, a protein that promotes neuronal growth and survival. It stimulates neurogenesis, the birth of new neurons in the hippocampus, a brain region crucial for memory. Exercise improves cognitive function, particularly executive functions like planning, working memory, and cognitive flexibility. It enhances mood and reduces symptoms of depression and anxiety. The mechanisms involve increased blood flow to the brain, reduced inflammation, enhanced neurotransmitter function, and direct effects of growth factors on neural tissue. Exercise-induced neuroplasticity is not limited to young brains. Older adults who exercise show better cognitive function and slower cognitive decline than sedentary peers. Even moderate exercise like regular walking produces measurable brain benefits. Understanding the neuroplastic effects of exercise provides a powerful, accessible intervention for brain health. Physical activity is not just good for your body, but essential for your brain, driving plasticity that enhances cognition, mood, and resilience. The mind-body connection works in both directions. Just as mental states affect the body, physical activity profoundly affects the mind. Sleep plays a crucial role in neuroplasticity, with memory consolidation and synaptic reorganization occurring primarily during sleep. During sleep, particularly during slow-wave sleep, the brain replays patterns of neural activity from waking experience, strengthening important connections and pruning unnecessary ones. This replay is essential for converting temporary memories into lasting ones, for integrating new learning with existing knowledge. Sleep deprivation impairs neuroplasticity, reducing the brain's ability to form new memories and learn new skills. It also impairs the pruning of unnecessary synapses, leading to inefficient neural networks. The synaptic homeostasis hypothesis proposes that waking experience strengthens synapses while sleep downscales them, preventing runaway strengthen and maintaining neural efficiency. Sleep is not just rest, but active neural reorganization, a time when the brain consolidates learning and optimizes its networks. Understanding the role of sleep in neuroplasticity highlights the importance of adequate sleep for learning, memory, and brain health. Chronic sleep deprivation doesn't just make you tired, it impairs the brain's ability to change and adapt, undermining learning and potentially contributing to cognitive decline. Prioritizing sleep is prioritizing neuroplasticity, giving your brain the time it needs to consolidate experience and reorganize itself. Environmental enrichment, exposure to complex, stimulating environments, drives neuroplasticity and enhances brain function. Studies in animals show that enriched environments with toys, social interaction, and opportunities for exploration increase neurogenesis, enhance synaptic density, and improve learning and memory. These effects are mediated by increased levels of growth factors, enhanced neural activity, and reduced stress. In humans, environmental enrichment takes the form of cognitive stimulation, social engagement, physical activity, and novelty. People who remain mentally and socially active throughout life show better cognitive function and lower risk of dementia. Conversely, social isolation and lack of stimulation are associated with cognitive decline. Environmental enrichment demonstrates that the brain needs stimulation to thrive. The plasticity is use-dependent and requires ongoing challenge and engagement. A stimulating environment keeps the brain plastic and healthy, while a barren environment allows neural networks to stagnate. Understanding environmental enrichment suggests that creating rich, engaging environments at home, at work, in communities is not just pleasant, but essential for brain health. The environment shapes the brain and optimizes neural function. The concept of cognitive reserve describes how lifetime experiences build brain resilience, protecting against cognitive decline and dementia. People with higher education, more cognitively demanding occupations, and greater engagement in mentally stimulating activities show better cognitive function in old age and lower dementia risk. Cognitive reserve appears to work through neuroplasticity. Enriching experiences build more robust, efficient neural networks with greater capacity to compensate for age-related changes or pathology. Two people with the same amount of Alzheimer's pathology in their brains may show very different cognitive symptoms, with the person with higher cognitive reserve maintaining better function despite the disease. Cognitive reserve is not fixed, but can be built throughout life through education, challenging work, learning new skills, and staying mentally engaged. Understanding cognitive reserve provides hope that cognitive decline is not inevitable, that lifestyle choices and experiences can build brain resilience. It also highlights the importance of lifelong learning and mental engagement, not just for enrichment, but for protecting brain health. Cognitive reserve demonstrates that the brain's plastic capacity, exercised throughout life, creates a buffer against aging and disease, that a life of mental engagement builds a brain better equipped to withstand the challenges of aging. Meditation produces measurable neuroplastic changes, with experienced meditators showing structural and functional differences in brain regions involved in attention, emotion regulation, and self-awareness. Mindfulness meditation, which involves sustained attention to present moment experience, increases gray matter density in the prefrontal cortex and hippocampus. It reduces activity in the default mode network, quieting self-referential thought. Compassion meditation, which involves cultivating feelings of loving kindness towards self and others, enhances activity in brain regions involved in empathy and emotion regulation. Even briefer meditation training, 8 weeks of daily practice, produces detectable brain changes. These changes are not just correlational, but causal. Meditation practice drives neuroplasticity that alters brain structure and function. The neuroplastic effects of meditation help explain its psychological benefits: improved attention, reduced stress and anxiety, enhanced emotional regulation, greater well-being. Meditation is a form of mental training that deliberately shapes the brain, strengthening circuits involved in beneficial mental states and weakening circuits involved in harmful ones. Understanding meditation-induced neuroplasticity reveals that contemplative practices are not just relaxation techniques, but powerful tools for brain change, methods for deliberately sculpting neural architecture in ways that enhance psychological health and well-being. Neuroplasticity in aging reveals that, while the brain's plastic capacity decreases with age, it never disappears entirely, and older brains remain capable of significant change. Older adults can learn new skills, form new memories, and show neuroplastic changes in response to training. Though learning may be slower and require more practice than in younger people, the aging brain shows reduced neurogenesis, decreased synaptic plasticity, and slower structural reorganization. However, these age-related declines can be partially offset by lifestyle factors. Physical exercise, cognitive engagement, social interaction, and stress management all promote neuroplasticity in older adults. Older adults who remain active and engaged show better cognitive function and slower decline than sedentary, isolated peers. Understanding neuroplasticity in aging challenges stereotypes of inevitable cognitive decline, revealing that the aging brain retains significant capacity for change and adaptation. While aging does reduce plasticity, it doesn't eliminate it, and the brain's plastic capacity can be maintained and even enhanced through appropriate lifestyle choices. This provides hope and agency, suggesting that how you age is partly under your control. The choices about activity, engagement, and learning can shape your brain's trajectory through later life. Meditation encompasses diverse practices with different techniques and goals, but most share the common feature of training attention and awareness. Focused attention meditation involves sustaining attention on a single object, like the breath, a mantra, or a visual image. When attention wanders, you notice and gently return it to the object. This practice strengthens attentional control and reduces mind-wandering. Open monitoring meditation involves observing whatever arises in awareness without focusing on any particular object, maintaining a receptive, non-reactive awareness of thoughts, sensations, and emotions. This practice enhances meta-awareness. Loving kindness meditation involves cultivating feelings of compassion and goodwill toward yourself and others through repeated phrases and imagery. This practice enhances positive emotions and social connection. Body scan meditation involves systematically directing attention through different parts of the body, noticing sensations without judgment. This practice enhances interoceptive awareness and reduces bodily tension. Understanding the diversity of meditation practices helps clarify that meditation is not a single technique, but a family of practices, each with somewhat different mechanisms and effects. Choosing the right practice depends on your goals and preferences, whether you want to improve attention, reduce stress, enhance compassion, or develop self-awareness. The neuroscience of meditation reveals that contemplative practices produce measurable changes in brain structure and function. Meditation affects multiple brain networks. It reduces activity in the default mode network, quieting the constant self-referential chatter that characterizes the resting mind. It enhances activity in attention networks, improving the ability to sustain focus and resist distraction. It modulates activity in emotion regulation networks, enhancing the prefrontal cortex's control over the amygdala, reducing emotional reactivity. Structural brain imaging shows that long-term meditators have increased gray matter density in regions including the prefrontal cortex, hippocampus, and insula. Even short-term meditation training produces detectable brain changes, with 8 weeks of mindfulness practice increasing gray matter in these same regions. The brain changes produced by meditation are not just correlational, but causal. Meditation practice drives neuroplasticity that alters neural architecture. These brain changes help explain meditation's psychological effects. The structural and functional changes in attention, emotion regulation, and self-awareness networks translate into improved mental function and well-being. Understanding the neuroscience of meditation reveals that contemplative practices are not mystical but biological, working through concrete changes in brain structure and function. Meditation affects the autonomic nervous system, shifting the balance from sympathetic to parasympathetic dominance, from stress response to relaxation response. During meditation, heart rate decreases, blood pressure drops, breathing slows and deepens, and stress hormone levels decline. These changes reflect increased parasympathetic activity, the rest and digest mode that promotes healing and restoration. With regular practice, these acute effects become trait effects. Meditators show lower baseline stress levels, reduced reactivity to stressors, and faster recovery after stress. Heart rate variability, an indicator of autonomic flexibility, increases with meditation practice, reflecting better autonomic balance. The autonomic effects of meditation health benefits: reduced blood pressure, improved immune function, better sleep, reduced inflammation. By shifting autonomic balance away from chronic stress response toward relaxation and restoration, meditation creates physiological conditions that support health and healing. Understanding meditation's autonomic effects reveals a key mechanism of mind over matter, showing how a mental practice can directly influence supposedly involuntary bodily functions, creating measurable changes in cardiovascular, immune, and endocrine systems. Meditation reduces inflammation, a key mechanism linking mind and body in health and disease. Chronic inflammation contributes to numerous health problems, including cardiovascular diseases, diabetes, cancer, depression, and neurodegenerative diseases. Stress increases inflammation through activation of the sympathetic nervous system and release of stress hormones. Meditation reduces inflammation through multiple pathways. It reduces stress and stress hormones, which directly suppress inflammatory signaling. It enhances parasympathetic activity, which has anti-inflammatory effects. It reduces activity in brain regions that promote inflammatory responses. Studies show that meditation practitioners have lower levels of inflammatory markers, including C-reactive protein and pro-inflammatory cytokines. Even brief meditation training can reduce inflammatory responses to stress. The anti-inflammatory effects of meditation help explain its broad health benefits. Inflammation is involved in so many diseases that reducing it has wide-ranging protective effects. Understanding meditation's anti-inflammatory effects provides a biological mechanism for mind-body healing, showing how a mental practice can influence cellular and molecular processes involved in disease, demonstrating that consciousness can reach down to the level of immune signaling and inflammatory cascades. Mindfulness, the quality of present moment awareness cultivated by meditation, has psychological benefits that extend beyond formal practice. Mindfulness involves paying attention to present experience with openness, curiosity, and acceptance, without judgment or reactivity. People high in trait mindfulness, whether from meditation practice or natural disposition, show better emotional regulation, lower stress and anxiety, reduced rumination, and greater well-being. Mindfulness helps break automatic patterns of reactivity, creating space between stimulus and response, where conscious choice becomes possible. Instead of automatically reacting to difficult emotions or situations, mindfulness allows you to observe them, understand them, and choose how to respond. This capacity for non-reactive awareness is particularly valuable for managing stress, anxiety, and depression, which often involve automatic patterns of negative thinking and emotional reactivity. Mindfulness-based interventions, which teach meditation and mindfulness skills, have proven effective for treating depression, anxiety, chronic pain, and substance abuse. Understanding mindfulness as a trainable mental quality, not just a meditation technique, suggests that its benefits can be cultivated and applied throughout daily life, transforming how you relate to experience and enhancing psychological resilience and well-being. Meditation affects gene expression, demonstrating that mental practices can influence the molecular machinery of cells. Studies using genomic analysis have found that meditation alters expression of genes involved in inflammation, stress response, and cellular metabolism. After meditation retreats, practitioners show downregulation of genes involved in inflammatory pathways and stress response, and upregulation of genes involved in immune function and cellular repair. These changes occur rapidly, within hours or days of intensive practice, and involve epigenetic mechanisms, changes in how genes are regulated rather than changes in the genes themselves. The fact that meditation can alter gene expression reveals a profound level of mind-body interaction, showing that mental states and practices can reach into the nucleus of cells and influence which genes are turned on or off. This provides a molecular mechanism for meditation's health effects. Changes in gene expression translate into changes in protein production, cellular function, and ultimately health outcomes. Understanding meditation's effects on gene expression demonstrates that mind over matter operates at the deepest biological levels, that consciousness can influence the fundamental processes of cellular life. The concept of mindfulness-based stress reduction, developed by John Kabat-Zinn, brought meditation into mainstream medicine and demonstrated its clinical effectiveness. MBSR is an 8-week program that teaches mindfulness meditation and yoga, helping participants develop present moment awareness and non-reactive observation of experience. MBSR was originally developed for chronic pain patients and proved remarkably effective, helping people reduce pain and improve quality of life, even when the underlying condition couldn't be cured. The program has since been applied to numerous conditions including anxiety, depression, stress-related disorders, and chronic illness. Research shows that MBSR produces significant improvements in psychological symptoms, quality of life, and even physical health markers. The success of MBSR demonstrates that meditation is not just a spiritual practice, but a clinical intervention with measurable health benefits. It also shows that meditation's benefits don't require years of practice. 8 weeks of training can produce meaningful improvements. Understanding MBSR's effectiveness and mechanisms has helped legitimize meditation in medical and scientific communities, showing that contemplative practices can be studied rigorously and applied clinically to reduce suffering and enhance well-being. Meditation enhances emotional regulation, the ability to manage and modulate emotional responses. Emotional regulation involves multiple processes, including recognizing emotions, understanding their causes, modulating their intensity, and choosing appropriate responses. Meditation enhances all these processes. It improves emotional awareness through enhanced interoception and mindfulness. It provides distance from emotions, allowing you to observe them without being overwhelmed. It strengthens prefrontal control over limbic regions, enhancing top-down regulations of emotional responses. Brain imaging shows that meditators have stronger connectivity between prefrontal cortex and amygdala, the brain's fear and emotion center, and show reduced amygdala reactivity to emotional stimuli. These neural changes translate into better emotional regulation in daily life. Meditators report less emotional reactivity, faster recovery from negative emotions, and greater emotional stability. Enhanced emotional regulation is one of meditation's most valuable benefits, contributing to reduced anxiety and depression, better relationships, and greater resilience to stress. Understanding how meditation enhances emotional regulation reveals another mechanism of mind over matter, showing how mental training can strengthen neural circuits that govern emotional life, creating lasting changes in how you experience and respond to emotions. The default mode network, active during mind-wandering and self-referential thought, is a key target of meditation's effects on the brain. The default mode network includes the medial prefrontal cortex, posterior cingulate cortex, and other regions that activate when you're not focused on external tasks, when your mind wanders to thoughts about yourself, your past, your future, your relationships. While some default mode activity is normal and healthy, excessive activity is associated with rumination, worry, and unhappiness. Studies show that people are less happy when mind-wandering than when focused on present experience. Even when the wandering thoughts are pleasant, meditation reduces default mode network activity, quieting the constant stream of self-focused thought. Experienced meditators show reduced default mode activity even during rest, suggesting lasting changes in how the brain operates. They also show different patterns of connectivity within the default mode network, with stronger connections between regions involved in self-monitoring and cognitive control. These changes help explain why meditation reduces rumination and enhances well-being by quieting the default mode network. Meditation reduces the constant self-focused chatter that often generates stress and unhappiness, creating more mental space for present moment experience. Meditation affects the perception of time, with practitioners often reporting that time seems to slow down or that they lose track of time entirely during practice. Research confirms these subjective reports, showing that meditation alters time perception in measurable ways. During meditation, people tend to underestimate how much time has passed, suggesting that subjective time slows. This time dilation may reflect enhanced present moment awareness. When you're fully engaged with present experience, each moment feels fuller and richer, creating a sense of expanded time. Meditation also affects the brain's timekeeping mechanisms, altering activity in regions involved in temporal processing. The slowing of subjective time during meditation may contribute to its stress-reducing effects, Stress often involves feeling rushed and time-pressured, while meditation creates a sense of spaciousness and timelessness. Understanding meditation's effects on time perception reveals another dimension of how mental practices alter experience, showing that consciousness doesn't just passively receive temporal information, but actively constructs the experience of time, and that this construction can be influenced by attention and awareness. Compassion meditation, which cultivates feelings of loving kindness and compassion towards self and others, produces distinct brain changes and psychological benefits. Compassion meditation involves generating feelings of warmth and care, often through repeated phrases like "may you be happy," "may you be healthy," "may you be safe," directed first toward yourself, then toward loved ones, neutral people, difficult people, and finally all beings. Brain imaging shows that compassion meditation enhances activity in regions involved in empathy, emotion regulation, and positive emotion, including the insular, anterior cingulate cortex, and ventral striatum. It increases connectivity between regions involved in empathy and those involved in positive emotion, potentially explaining how compassion meditation can transform empathetic distress into compassionate concern. Psychological studies show that compassion meditation increases positive emotions, social connection, and pro-social behavior, while reducing negative emotions and social isolation. Even brief compassion meditation training can increase helping behavior and reduce implicit bias. Understanding compassion meditation reveals that emotions like kindness and compassion are not just spontaneous feelings, but trainable skills that can be cultivated through practice, that the capacity for care and connection can be deliberately strengthened through mental training. Meditation affects pain perception, demonstrating that mental practices can modulate even intense physical sensations. Studies using experimental pain show that meditation reduces pain intensity and unpleasantness, with experienced meditators showing particularly large reductions. Brain imaging reveals that meditation reduces pain through multiple mechanisms. It reduces activity in pain-processing regions, including the anterior cingulate cortex and insula. It enhances activity in prefrontal regions involved in cognitive control and emotion regulation. It alters the relationship between pain sensation and pain-related suffering, reducing the emotional and evaluative components of pain while leaving the sensory component relatively intact. Interestingly, meditation's pain-reducing effects don't depend entirely on endogenous opioids, the brain's natural painkillers, suggesting that meditation uses different pain modulators mechanisms than placebo analgesia. Clinical studies show that meditation-based interventions can help people with chronic pain reduce pain intensity, improve function, and enhance quality of life. Understanding meditation's effects on pain reveals the constructed nature of pain experience, showing that pain is not simply a direct readout of tissue damage, but a complex experience shaped by attention, expectation, and emotional state, and that mental training can alter this construction, providing genuine relief. The concept of neuroplasticity underlies meditation's effects, with contemplative practices driving brain changes through repeated mental training. Meditation is essentially a form of mental exercise. Just as physical exercise strengthens muscles and cardiovascular system, mental exercise strengthens neural circuits. The specific circuits that are strengthened depend on the type of meditation practiced. Focused attention meditation strengthens attention networks. Open monitoring meditation enhances meta-awareness networks. Compassion meditation strengthens empathy and positive emotion networks. These training effects follow the basic principles of neuroplasticity. Neurons that fire together wire together, and use it or lose it. the mental states and processes you repeatedly engage during meditation become stronger and more accessible, while those you don't engage become weaker. This explains why meditation's benefits persist beyond formal practice. The brain changes created by meditation alter how neural circuits function in daily life, making beneficial mental states more accessible and harmful ones less dominant. Understanding meditation through the lens of neuroplasticity demystifies its effects, revealing that contemplative practices work through the same brain mechanisms as other forms of learning, that meditation is mental training that deliberately shapes neural architecture in beneficial ways. Telomeres are protective caps on the ends of chromosomes that shorten with each cell division, serving as a biological clock that limits cellular lifespan. When telomeres become too short, cells can no longer divide and enter senescence or die. Telomere length is associated with aging and age-related diseases. People with shorter telomeres show accelerated aging, higher disease risk, and shorter lifespan. Telomere shortening is not just a passive consequence of aging, but is influenced by numerous factors, including stress, lifestyle, and psychological state. Chronic stress accelerates telomere shortening, while stress management, exercise, and healthy diet slow. The discovery that telomere length is modifiable, not fixed, revolutionized understanding of aging, suggesting that biological aging is not entirely determined by genetics, but can be influenced by behavior and environment. Telomeres provide a cellular mechanism linking mind and body, a way that psychological factors can influence the fundamental biology of aging. Understanding telomeres reveals that aging happens at the cellular level, that each cell carries a biological clock, and that this clock can be influenced by how you live and think, providing a concrete mechanism for mind over matter in the aging process. Telomerase is an enzyme that rebuilds telomeres, counteracting the shortening that occurs with cell division. Most adult cells have low telomerase activity, allowing telomeres to shorten with age. However, telomerase activity can be increased by various factors, including exercise, meditation, and stress reduction. Studies show that meditation practitioners have higher telomerase activity than controls, suggesting that contemplative practices may slow cellular aging. Lifestyle interventions combining diet, exercise, and stress management can increase telomerase activity and even lengthen telomeres. The fact that telomerase activity can be influenced by behavior and mental state provides a mechanism for mind-body effects on aging, showing that psychological factors can reach into cells and influence the enzymes that maintain chromosomes. Telomerase reveals that cellular aging is not entirely predetermined, but responsive to experience and lifestyle. This provides hope that aging can be slowed or even partially reversed through appropriate interventions, that biological age is not the same as chronological age, and that choices about how you live and manage stress can influence how quickly your cells age. Chronic stress accelerates cellular aging through multiple mechanisms, including telomere shortening, increased oxidative stress, and enhanced inflammation. Psychological stress triggers physiological stress responses, release of cortisol and other stress hormones, activation of the sympathetic nervous system, increased inflammation. When these responses are chronic, they damage cells and accelerate aging. Stress increases oxidative stress, an imbalance between free radicals and antioxidants that damages DNA, proteins, and lipids. Stress promotes inflammation, which contributes to age-related diseases. Stress shortens telomeres both directly through oxidative damage and indirectly by reducing telomerase activity. Studies show that people experiencing chronic stress from caregiving, trauma, or chronic life difficulties have shorter telomeres and accelerated cellular aging. The effects of stress on cellular aging demonstrate that psychological factors have real biological consequences, that mental suffering translates into physical aging at the cellular level. Understanding how stress accelerates aging highlights the importance of stress management, not just for mental health, but for physical health and longevity, showing that managing your mind is managing your cellular biology. Meditation and mindfulness practices appear to slow cellular aging, with studies showing that meditators have longer telomeres and higher telomerase. A landmark study found that participants in a 3-month meditation retreat showed increased telomerase activity compared to controls. Other studies have found that long-term meditators have longer telomeres than age-matched controls. The mechanisms likely involve reduced stress and stress hormones, decreased inflammation, and enhanced parasympathetic activity, all of which protect telomeres and support telomerase function. Meditation's effects on cellular aging provide a concrete biological mechanism for its health benefits, showing that contemplative practices don't just make you feel better, but actually slow aging at the cellular level. This suggests that meditation is not just a psychological intervention, but a biological one, influencing fundamental processes of cellular maintenance and aging. Understanding meditation's effects on telomeres reveals another dimension of mind over matter, showing that mental practices can influence the molecular machinery that determines cellular lifespan, that consciousness can reach into the nucleus and affect the chromosomes themselves. Psychological resilience, the ability to adapt successfully to stress and adversity, is associated with slower cellular aging and longer telomeres. People who cope effectively with stress, who maintain positive emotions and social connections despite difficulties, show less telomere shortening than those who struggle with stress. Resilience appears to buffer the effects of stress on cellular aging, preventing stress from translating into biological damage. The mechanisms may involve better stress regulation, lower chronic stress hormone levels, reduced inflammation, and healthier lifestyle behaviors. Resilience is not just a fixed trait, but can be cultivated through various practices, including meditation, cognitive therapy, social connection, and physical exercise. Understanding the link between resilience and cellular aging suggests that building psychological resilience is not just about mental health, but about physical health and longevity. It provides motivation for developing resilient skills and suggests that psychological interventions targeting resilience could have anti-aging effects. The resilience telomere connection demonstrates that how you respond to life's challenges affects not just your mental state, but your cellular biology. That psychological adaptation has biological consequences at the most fundamental level. The concept of biological age versus chronological age highlights that aging is not just about how many years you've lived, but about the condition of your cells and tissues. Two people of the same chronological age can have very different biological ages depending on their genetics, lifestyle, and psychological state. Biological age can be assessed through various biomarkers, including telomere length, DNA methylation patterns, and physiological measures like blood pressure and lung function. People with younger biological age than chronological age tend to be healthier, more functional, and longer lived than those with older biological age. Importantly, biological age is modifiable. Lifestyle interventions can reduce biological age, making cells and tissues functionally younger. Exercise, healthy diet, stress management, and social connection all contribute to younger biological age. Understanding the distinction between biological age provides hope that aging is not entirely fixed, that you have some control over how quickly you age biologically. It also provides concrete targets for anti-aging interventions. Rather than trying to stop time, we can try to slow biological aging, keeping cells and tissues functioning well despite advancing years. Oxidative stress, an imbalance between free radicals and antioxidants, is a key mechanism of cellular aging and is influenced by psychological factors. Free radicals are reactive molecules produced during normal metabolism that can damage DNA, proteins, and lipid. Antioxidants neutralize free radicals, preventing damage. When free radical production exceeds antioxidant capacity, oxidative stress results, contributing to aging and age-related diseases. Psychological stress increases oxidative stress through multiple pathways, including increased metabolism, inflammation, and stress hormone effects. Chronic stress depletes antioxidant defenses while increasing free radical production, creating a damaging imbalance. Conversely, stress-reducing practices like meditation and exercise enhance antioxidant defenses and reduce free radical production. The link between psychological stress and oxidative stress provides another mechanism for mind-body effects on aging, showing how mental state can influence the chemical balance within cells. Understanding oxidative stress highlights the importance of both psychological and lifestyle interventions for healthy aging, suggesting that managing stress and maintaining healthy behaviors work together to protect cells from oxidative damage. Inflammation is a key driver of aging and age-related disease and is strongly influenced by psychological factors. Chronic low-grade inflammation, sometimes called inflammation, increases with age and contributes to cardiovascular disease, diabetes, cancer, Alzheimer's disease, and other age-related conditions. Psychological stress promotes inflammation through activation of inflammatory signaling pathways and release of pro-inflammatory cytokines. Depression is associated with elevated inflammation, which may contribute to its physical health consequences. Loneliness and social isolation increase inflammation, while social connection and positive emotions reduce it. Meditation and other mind-body practices reduce inflammation through multiple mechanisms, including reduced stress, enhanced parasympathetic activity, and altered gene expression. The strong link between psychological factors and inflammation demonstrates that mental and emotional states have profound effects on immune function and inflammatory processes. Understanding this link suggests that psychological interventions could help prevent or treat inflammatory diseases, that managing your mind is managing your inflammatory state, and that consciousness can influence the immune system's inflammatory responses. The concept of psychoneuroimmunology, the study of interactions between psychological processes, the nervous system, and the immune system, provides a framework for understanding how thoughts affect cellular function. The immune system, once thought to operate independently, is now known to be under significant influence from the brain and psychological state. Stress suppresses immune function, reducing the activity of immune cells and increasing susceptibility to infection. Positive emotions and social connection enhance immune function, improving resistance to illness. The mechanisms involve stress hormones, autonomic nervous system activity, and direct neural connections to immune organs. Psychological factors also influence immune-related processes like inflammation and wound healing. Understanding psychoneuroimmunology reveals that immunity is not just a biological defense system, but is integrated with psychological and neural systems. That mental state affects how well your body can defend against pathogens and heal from injury. This integration provides multiple pathways for mind to influence matter at the cellular level, showing that consciousness affects not just brain cells, but immune cells throughout the body. Sleep quality affects cellular aging, with poor sleep accelerating telomere shortening and biological aging. Sleep is essential for cellular repair and maintenance. During sleep, cells clear out damaged proteins, repair DNA, and restore energy reserves. Sleep deprivation impairs these repair processes, leading to accumulated cellular damage. Studies show that people with chronic sleep problems have shorter telomeres and accelerated cellular aging. Sleep disorders like insomnia and sleep apnea are associated with increased inflammation, oxidative stress, and metabolic dysfunction, all of which contribute to aging. Conversely, good sleep quality protects against cellular aging, supporting repair processes and reducing stress. The link between sleep and cellular aging highlights that sleep is not just rest but active cellular maintenance, that what happens during sleep affects the fundamental biology of aging. Understanding this link provides motivation for prioritizing sleep and treating sleep disorders, suggesting that improving sleep quality could slow biological aging and extend health span. The number of years lived in good health. Social connection and relationship quality affect cellular aging, with loneliness and social isolation accelerating aging, while strong relationships protect against it. Studies show that lonely people have shorter telomeres, higher inflammation, and accelerated biological aging compared to socially connected people. The mechanisms likely involve chronic stress, as loneliness is a potent stressor, as well as behavioral factors like poorer health habits among isolated people. Social connection appears to buffer stress and promote health through multiple pathways, including emotional support, practical help, and positive emotions. The quality of relationships matters more than quantity. Supportive, positive relationships protect health, while conflictual, negative relationships may harm it. Understanding the link between social connection and cellular aging reveals that relationships are not just psychologically important, but biologically important, that who you spend time with affects how quickly your cells age. This provides scientific support for the importance of nurturing relationships and building community, suggesting that social connection is not a luxury but a biological necessity that influences fundamental processes of aging and health. Purpose in life, the sense that your life has meaning and direction, is associated with slower cellular aging and better health outcomes. People with strong sense of purpose have longer telomeres, lower inflammation, and reduced risk of age-related diseases including cardiovascular disease and Alzheimer's disease. Purpose appears to protect health through multiple mechanisms including better stress regulation, healthier behaviors, and enhanced immune function. People with purpose may cope better with stress, maintain healthier lifestyles, and have more resilient immune systems. The link between purpose and cellular aging suggests that existential and psychological factors, not just physical ones, influence biological aging. Finding meaning and purpose in life is not just philosophically valuable but biologically protective, influencing how quickly your cells age and how well your body functions. Understanding this link highlights the importance of cultivating purpose, whether through work, relationships, creative pursuits, or service to others, suggesting that a meaningful life is not just a good life, but a longer, healthier life. Mental imagery, the ability to create sensory experiences in your mind, activates many of the same brain regions as actual perception and action. When you imagine seeing something, your visual cortex activates. When you imagine moving, your motor cortex activates. When you imagine hearing music, your auditory cortex activates. This neural overlap between imagery and perception means that mental practice can drive some of the same brain changes as physical practice. The brain doesn't completely distinguish between imagined and real experience, treating vivid mental imagery as a form of simulated experience that can be used for learning and preparation. This neural similarity underlies the effectiveness of mental practice and visualization. The brain rehearses actions and experiences through imagery, strengthening the relevant neural circuits, even without physical movement. Understanding mental imagery reveals that the mind can create internal experiences that have real neural consequences, that imagination is not just fantasy, but a tool for shaping brain and behavior. Mental imagery demonstrates a form of mind over matter, where purely mental activity, visualization without physical action, can influence neural structure and function. Athletes use mental practice and visualization to enhance performance, imagining themselves executing skills perfectly to strengthen motor programs and build confidence. Mental practice involves systematically rehearsing movements in your mind, visualizing every detail of the action, the sensations, the movements, the outcome. Studies show that mental practice improves performance, though not as much as physical practice. The most effective approach combines mental and physical practice, using visualization to supplement actual training. Mental practice works through multiple mechanisms. It strengthens motor programs in the brain, the neural patterns that control movement. It enhances motor planning and sequencing. It builds confidence and reduces anxiety. It allows practice of skills that are difficult or dangerous to practice physically. Elite athletes routinely use visualization as part of their training, mentally rehearsing competitions, imagining successful performances, and preparing for various scenarios. Understanding mental practice in athletics demonstrates that performance is not just about physical ability, but about mental preparation, that the brain's motor systems can be trained through imagination, and that visualization is a legitimate training tool that enhances physical performance through neural mechanisms. Motor imagery, imagining movements without executing them, activates motor cortex and other brain regions involved in movement planning and execution. Brain imaging shows that imagining a movement activates similar patterns of brain activity as actually performing the movement, though typically with lower intensity. This activation includes primary motor cortex, premotor cortex, supplementary motor area, and cerebellum. The similarity between imagined and actual movement at the neural level explains why mental practice can improve motor skills. When you imagine a movement, you're activating and strengthening the same neural circuits that control actual movement. This strengthening translates into improved performance when you actually execute the movement. Motor imagery is used not just in sports, but in rehabilitation after stroke or injury, helping patients maintain or rebuild motor programs when physical practice is limited. Understanding motor imagery reveals that movement is not just a physical act, but a mental one, that the neural programs controlling movement can be accessed and strengthened through imagination, demonstrating that mind can influence motor matter, that purely mental rehearsal can enhance physical performance. Visualization affects physiological responses, with imagined experiences triggering some of the same bodily changes as real experiences. When you vividly imagine exercising, your heart rate and breathing increase, though not as much as during actual exercise. When you imagine eating, you salivate. When you imagine stressful situations, your stress hormones increase. This physiological responsiveness to imagery demonstrates that the body responds to mental representations, not just to external reality. The brain generates predictions about what should happen based on your mental imagery, and the body begins to prepare accordingly. This mind-body connection through imagery can be harnessed therapeutically. Imagining relaxing scenes can trigger the relaxation response, reducing stress, and promoting calm. Imagining healing can enhance immune function and recovery. The fact that imagination can trigger physiological changes reveals another dimension of mind over matter, showing that purely mental activity, without any external stimulus, can influence bodily states, that the body responds to the mind's internal representations as if they were real. The concept of mental simulation describes how the brain uses imagination to prepare for future actions and events. Mental simulation involves creating detailed mental models of possible futures, imagining how events might unfold and how you might respond. This simulation serves multiple functions. It allows you to practice responses to situations before they occur, preparing motor programs and decision strategies. It helps you anticipate obstacles and plan solutions. It allows you to evaluate different courses of action without the risks of actual trial and error. Mental simulation engages many brain regions, including prefrontal cortex for planning, motor areas for action preparation, and limbic regions for emotional evaluation. Athletes use mental simulation to prepare for competitions, imagining various scenarios and their responses. Surgeons use it to rehearse complex procedures. Anyone can use it to prepare for challenging situations, job interviews, difficult conversations, public speaking. Understanding mental simulation reveals that the mind is not just reactive, but proactive, using imagination to shape future behavior. That mental rehearsal prepares brain and body for action, demonstrating how consciousness can influence future performance through present mental activity. Biofeedback uses real-time monitoring of physiological signals to teach conscious control of bodily functions. Biofeedback devices measure signals like heart rate, skin temperature, muscle tension, or brain waves, and display them to the user. By observing these signals, people can learn to influence them, discovering mental strategies that produce desired physiological changes. Biofeedback has been used successfully to treat numerous conditions including chronic pain, headaches, hypertension, anxiety, and incontinence. The training works by making normally unconscious physiological processes visible, allowing conscious experimentation with different mental states and strategies. People discover that certain thoughts, images, or breathing patterns produce desired changes in their physiology. With practice, this control becomes more automatic and can be deployed without the feedback device. Biofeedback demonstrates that the boundary between voluntary and involuntary is permeable, that conscious intention can reach into autonomic processes and exert genuine influence. It provides a technology-assisted method for developing mind-body control, showing that with appropriate feedback, people can learn to influence physiological processes once thought to be completely automatic. Neurofeedback, a specific type of biofeedback that targets brain activity, allows people to learn to modulate their own brain waves. Neurofeedback uses EEG to monitor brain electrical activity and provides real-time feedback, often in the form of a game or visual display that responds to brain state. People learn to produce desired brain states, like increased alpha waves for relaxation or increased beta waves for focus, by discovering mental strategies that produce the target pattern. Neurofeedback has been used to treat ADHD, anxiety, depression, epilepsy, and other conditions. While the evidence for neurofeedback is mixed and more research is needed, some studies show promising results. The principle behind neurofeedback is that brain states are not entirely automatic, but can be influenced by conscious intention, that with appropriate feedback, people can learn to shift their brain activity in beneficial directions. Neurofeedback represents a direct form of mind over brain, where conscious effort, guided by real-time feedback, shapes neural activity patterns, demonstrating that consciousness can modulate its own neural substrate. The concept of embodied simulation describes how understanding and empathy involve simulating others' experiences in your own brain and body. When you observe someone performing an action, your motor system activates as if you were performing the action yourself, though at a lower level that doesn't produce actual movement. When you observe someone experiencing an emotion, your emotional systems activate, creating a resonant emotional response. This simulation allows you to understand others' actions and feelings by recreating them internally. Mirror neurons, which fire both when you act and when you observe others acting, are thought to play a key role in embodied simulation. This simulation is not just neural, but bodily. Observing someone in pain activates your own pain systems. Observing someone's facial expression triggers subtle mimicry in your own face. Embodied simulation reveals that understanding is not purely cognitive, but involves recreating others' experiences in your own mind and body. It demonstrates that the boundary between self and other is permeable at the neural level, that your brain and body resonate with others' states, creating a foundation for empathy and social connection. Guided imagery is a therapeutic technique that uses directed visualization to promote healing and well-being. A therapist or recording guides you through detailed imaginary scenarios designed to promote relaxation, reduce pain, enhance immune function, or address psychological issues. For example, cancer patients might be guided to imagine their immune cells attacking cancer cells. Pain patients might imagine pain as a color or shape that gradually fades or dissolves. Anxious people might imagine a peaceful, safe place where they can relax completely. Research shows that guided imagery can reduce pain, anxiety, and stress, improve sleep, and enhance immune function. The mechanisms likely involve the relaxation response, the placebo effect, and the physiological effects of mental imagery. Guided imagery harnesses the mind's capacity to influence the body through imagination, using vivid mental scenarios to trigger beneficial physiological changes. Understanding guided imagery reveals that therapeutic interventions don't have to be purely physical or chemical, that carefully crafted mental experiences can promote healing, demonstrating the therapeutic potential of imagination and the power of mind to influence bodily health. The phenomenon of ideomotor action describes how thoughts about movement can trigger actual movement, usually subtle and unconscious. When you think about moving, your motor system activates slightly, sometimes enough to produce small movements even without conscious intention to move. This is why a Ouija board planchette moves. Participants' unconscious ideomotor movements, guided by their expectations, move the planchette. Ideomotor action demonstrates that the boundary between thought and action is not absolute, that motor thoughts can leak into motor action. This has implications for understanding how mental imagery affects performance. Part of the benefit may come from ideomotor activation that subtly primes the motor system. It also reveals that thoughts are not purely mental, that have physical correlates, that thinking about action involves partial activation of action systems. Ideomotor action is another example of mind influencing matter, showing that mental activity can directly trigger physical movement, that the gap between intention and action is smaller than it seems, that thought and movement are intimately connected at the neural level. The concept of mental contrasting combines visualization of desired outcomes with consideration of obstacles, creating more effective goal pursuit than positive visualization alone. Mental contrasting involves first imagining achieving your goal in vivid detail, then identifying and imagining the obstacles that might prevent success. This combination creates a sense of energized commitment. The positive imagery provides motivation, while the obstacle imagery prompts planning and problem solving. Research shows that mental contrasting is more effective for goal achievement than either positive visualization alone or dwelling on obstacles alone. The technique works by creating a mental association between the desired future and present obstacles, priming you to overcome obstacles when they arise. Mental contrasting demonstrates that effective use of visualization requires balance. Pure positive thinking can be motivating, but may not prepare you for challenges, while focusing only on obstacles can be discouraging. The combination harnesses the motivational power of positive imagery while maintaining realistic awareness of challenges, creating a mental state that promotes effective action. Visualization affects confidence and self-efficacy, the belief in your ability to succeed. When you repeatedly visualize yourself successfully performing a task, you build confidence in your ability to actually perform it. This confidence can become self-fulfilling as higher self-efficacy leads to greater effort, persistence, and ultimately better performance. Athletes who visualize successful performances report feeling more confident and prepared. Students who visualize themselves succeeding on exams perform better and feel less anxious. The mechanism involves both the neural strengthening from mental practice and the psychological boost from imagining success. Visualization creates a sense of familiarity with success, making it feel more achievable. It also provides evidence to yourself that you can succeed, even if that evidence is imaginary. Understanding how visualization builds confidence reveals another pathway from mind to performance, showing that mental preparation affects not just skills but beliefs, and that these beliefs influence actual outcomes, creating a cycle where visualization enhances confidence, which enhances performance. The use of visualization in pain management demonstrates that mental imagery can modulate even intense physical sensations. Pain patients are taught to use imagery techniques, like imagining pain as a color that fades, visualizing healing light flowing to painful areas, or mentally traveling to peaceful, pain-free places. Research shows that these techniques can reduce pain intensity and improve quality of life. The mechanisms likely involve attention, distraction from pain, activation of pain modulation systems, and the relaxation response. Visualization gives patients a sense of control over their pain, shifting from passive suffering to active management. This sense of control itself can reduce pain, as helplessness amplifies suffering. Understanding visualization in pain management reveals that pain is not just a sensory signal, but a complex experience shaped by attention, emotion, and meaning, and that mental techniques can alter this experience, providing genuine relief. It demonstrates that mind can modulate the matter of pain, that imagination can influence how pain is processed and experienced. The mind-body connection in healing has been recognized across cultures and throughout history, with traditional healing systems emphasizing the role of mental and spiritual factors in health and recovery. Ancient medical traditions, including traditional Chinese medicine, Ayurveda, and indigenous healing practices, all recognize that health involves balance of mental, emotional, and physical factors. Modern medicine, with its focus on biological mechanisms, sometimes neglects these connections, but research increasingly validates the importance of psychological factors in healing. Patients who are hopeful, engaged, and supported heal faster and better than those who are hopeless, passive, and isolated. The mechanisms involve stress hormones, immune function, inflammation, and health behaviors. Understanding the mind-body connection in healing doesn't mean rejecting modern medicine, but integrating it with attention to psychological and social factors. Healing is not just a biological process, but a whole-person process involving mind, body, relationships, and meaning. Recognizing this integration can enhance medical care and improve outcomes, showing that the most effective healing addresses not just diseased tissues but the whole person. The concept of psychosomatic illness describes conditions where psychological factors play a significant role in physical symptoms. Psychosomatic doesn't mean imaginary or fake. It means that mind and body are both involved in creating real physical symptoms. Stress can trigger or worsen numerous conditions, including irritable bowel syndrome, tension headaches, chronic pain, asthma, and skin conditions. The mechanisms involve the stress response, autonomic nervous system, immune function, and inflammation. Psychological factors can also affect how symptoms are experienced and reported, with anxiety amplifying pain and other sensations. Understanding psychosomatic illness reveals that the mind-body distinction is artificial, that psychological and physical factors are always intertwined in illness and health. It also suggests that treating psychosomatic conditions requires addressing both psychological and physical factors, that purely medical treatment may be insufficient if psychological factors are driving symptoms. The concept of psychosomatic illness demonstrates that mind and matter are not separate in disease, that psychological suffering can manifest as physical symptoms, and that healing requires attention to both dimensions. The role of hope and optimism in healing is well documented, with hopeful patients showing better outcomes across numerous conditions. Hope is not just a pleasant feeling but a physiological state that influences healing through multiple pathways. Hopeful people have lower stress hormones, better immune function, reduced inflammation, and healthier behaviors. They're more likely to adhere to treatment, seek social support, and maintain healthy lifestyles. Hope also enhances the placebo effect, as hopeful expectations trigger healing responses. The mechanisms involve the brain's reward system, which is activated by hopeful thoughts about the future, and the stress system, which is dampened by hope. Hopelessness, conversely, is associated with worse outcomes, higher mortality, and poorer quality of life. Understanding the role of hope in healing suggests that fostering hope should be a priority in medical care, that how doctors communicate, whether they offer hope or convey hopelessness, can influence outcomes. Hope is not just psychological comfort, but a biological force that promotes healing, demonstrating that mental states have real consequences for physical health. Social support affects healing and health outcomes, with socially connected people recovering faster from illness and living longer than isolated people. Social support works through multiple mechanisms. It provides emotional comfort, reducing stress, and promoting positive emotions. It provides practical help with daily tasks and medical care. It enhances adherence to treatment through encouragement and accountability. It may directly affect physiology, with social connection reducing stress hormones and inflammation. Loneliness and social isolation, conversely, are associated with worse health outcomes, higher mortality, and slower recovery from illness. The health effects of social connection are comparable in magnitude to the effects of smoking, obesity, and physical inactivity, highlighting the importance of relationships for health. Understanding the role of social support in healing reveals that health is not just an individual matter, but a social one. That who you're connected to affects how well you heal. It suggests that medical care should attend to patients' social circumstances, and that fostering connection should be part of healing. The concept of salutogenesis, developed by Aaron Antonovsky, focuses on factors that promote health rather than just factors that cause disease. Salutogenesis asks what keeps people healthy despite stress and adversity, rather than just what makes people sick. The key concept is sense of coherence, a global orientation that life is comprehensible, manageable, and meaningful. People with strong sense of coherence cope better with stress, maintain better health, and recover better from illness. Sense of coherence involves three components: comprehensibility, the sense that life makes sense; manageability, the sense that you have resources to cope with challenges; and meaningfulness, the sense that life is worth engaging with. These components can be strengthened through experiences of mastery, supportive relationships, and engagement with meaningful activities. Understanding salutogenesis shifts focus from pathology to health, from what's wrong to what's right, from disease to wellness. It suggests that promoting health requires not just preventing disease, but fostering the psychological and social resources that support resilience and well-being. The phenomenon of spontaneous remission, where serious illnesses sometimes resolve without medical treatment, suggests that the body has powerful self-healing capacities that are not fully understood. While spontaneous remission is rare, it has been documented in various conditions including cancer, autoimmune disease, and infections. The mechanisms are unclear but may involve immune system activation, psychological factors, lifestyle changes, or simply natural variability in disease progression. Some cases of spontaneous remission follow significant psychological or spiritual experiences, changes in attitude, resolution of conflicts, or profound shifts in how people relate to their illness. While these associations are intriguing, they're difficult to study rigorously, and it's unclear whether psychological changes cause remission or are simply coincidental. Understanding spontaneous remission reminds us that healing is not entirely predictable or controllable, that the body has capacities beyond what medicine can currently explain or harness. It suggests humility about medical knowledge and openness to the possibility that mind, meaning, and mystery play roles in healing that science has yet to fully understand. The role of meaning and purpose in healing reflects the existential dimension of illness and recovery. Serious illness often triggers existential questions about meaning, mortalis, and what matters in life. How people answer these questions affects their experience of illness and their healing. People who find meaning in their illness, who see it as an opportunity for growth or a call to change, often cope better and may have better outcomes than those who see illness as purely negative. Meaning can come from various sources: relationships, spirituality, creative expression, service to others, or simply the determination to live fully despite illness. The mechanisms linking meaning to healing likely involve stress reduction, enhanced motivation for self-care, stronger social connections, and positive emotions. Understanding the role of meaning in healing suggests that medical care should attend existential and spiritual concerns, not just biological ones, that helping patients find meaning in their experience can support healing. Meaning demonstrates that healing is not just physical but existential, that how you make sense of illness affects how you experience and recover from it. Mind-body interventions, including meditation, yoga, tai chi, and relaxation techniques, are increasingly integrated into medical care as complementary approaches to conventional treatment. These interventions work through multiple mechanisms including stress reduction, enhanced parasympathetic activity, reduced inflammation, improved immune function, and better health behaviors. Research shows that mind-body interventions can help manage numerous conditions, including chronic pain, anxiety, depression, insomnia, hypertension, and inflammatory diseases. They're generally safe low-cost and empowering, giving patients active tools for self-care. The integration of mind-body interventions into mainstream medicine reflects growing recognition that psychological factors are not separate from physical health, but integrating mind and body together produces better outcomes than addressing either alone. Understanding mind-body interventions reveals that healing can be enhanced by practices that engage consciousness, attention, and awareness, that mental training can support physical health, demonstrating practical applications of mind over matter in medical care. The concept of narrative medicine emphasizes the importance of patient stories in understanding and treating illness. Illness is not just a biological event, but a life event with personal meaning, and understanding this meaning requires listening to patients' narratives. How people tell their illness story, whether as tragedy, challenge, transformation, or injustice, affects how they experience and cope with illness. Narrative medicine involves eliciting and attending to these stories, recognizing that they provide crucial information about patients' experiences, values, and needs. Helping patients reshape their narratives, finding new meanings or perspectives, can support healing. The narrative approach recognizes that healing is not just about fixing bodies, but about helping people make sense of their experience and maintain their sense of self despite illness. Understanding narrative medicine reveals that illness is not just a medical problem but a human problem, that healing requires attention to meaning and story, not just symptoms and biology. It demonstrates that how we talk about and make sense of illness affects the experience of illness, showing another dimension of how mind influences the matter of health and disease. The role of ritual in healing is recognized across cultures, with healing rituals providing structure, meaning, and community support for people facing illness. Rituals work through multiple mechanisms. They provide a sense of control and agency in situations that feel chaotic and uncontrollable. They create meaning, framing illness within larger cultural or spiritual narratives. They mobilize social support, bringing community together around the sick person. They may trigger placebo effects through expectation and belief. Modern medicine has its own rituals: the white coat, the examination, the prescription, which carry meaning and can influence outcomes. Understanding the role of ritual in healing suggests that the ceremonial aspects of medical care matter, that how treatment is delivered with what solemnity and care affects its impact. Ritual demonstrates that healing is not just a technical process, but a meaningful one, that the symbolic and social dimensions of healing are as important as the biological ones, showing how consciousness, culture, and community influence the physical process of recovery. The phenomenon of healing presence describes the therapeutic effect of simply being with someone in a caring, attentive way. Healthcare providers who are fully present, who listen deeply and respond with compassion, produce better outcomes than those who are distracted or dismissive, even when providing the same medical treatment. Healing presence involves attention, empathy, and genuine care. It communicates that the patient matters, that they're not alone, that someone understands and cares about their suffering. This presence can reduce anxiety, enhance hope, strengthen the therapeutic relationship, and improve adherence to treatment. The mechanisms may involve stress reduction, enhanced placebo effects, and better communication leading to more appropriate care. Understanding healing presence reveals that the relationship between healer and patient is itself therapeutic, that how care is delivered is as important as what care is delivered. It demonstrates that consciousness, in the form of attention and compassion, can influence healing, that the quality of human connection in medical care affects physical outcomes. the integration of mind and body in healing challenges the traditional medical model that treats the body as a machine separate from the mind. This integration recognizes that every physical illness has psychological dimensions, and every psychological problem has physical dimensions. That mind and body are not separate but aspects of a unified whole. This recognition doesn't diminish the importance of biological medicine but enriches it, suggesting that the most effective healing addresses the whole person: biological, psychological, social, and spiritual. Integrated care combines conventional medical treatment with attention to psychological factors, social support, lifestyle, and meaning. This approach is not alternative medicine, but comprehensive medicine, recognizing that healing is a complex process involving multiple interacting factors. Understanding the integration of mind and body in healing represents a paradigm shift in medicine, from a purely biomedical model to a biopsychosocial model that recognizes the full complexity of human health and illness, demonstrating that mind over matter is not mystical, but fundamental to understanding and promoting healing. Brain-computer interfaces represent a direct technological connection between mind and matter, allowing thoughts to control external devices. BCIs read brain signals, typically through EEG or implanted electrodes, and translate them into commands that control computers, prosthetic limbs, or other devices. People with paralysis have used BCIs to control robotic arms, type messages, and even walk with exoskeletons, all through thought alone. BCIs work by detecting patterns of neural activity associated with intended movements or commands, then using machine learning to translate these patterns into device control. As the technology improves, BCIs may allow increasingly sophisticated control, potentially restoring function to people with severe disabilities. BCIs represent the most literal form of mind over matter, where neural activity, the physical substrate of thought, directly controls external physical systems. Understanding BCIs reveals that the boundary between mind and world can be bridged technologically, that thoughts can be translated into physical action through artificial systems, opening possibilities for human enhancement and restoration of function that were once science fiction. Neurostimulation techniques including transcranial magnetic stimulation and transcranial direct current stimulation allow external modulation of brain activity, offering new ways to influence mind through matter. TMS uses magnetic fields to stimulate specific brain regions, while TDCS uses weak electrical currents to modulate neural excitability. These techniques can enhance or suppress activity in targeted brain areas, potentially treating depression, chronic pain, stroke recovery, and other conditions. They can also enhance cognitive function, with stimulation of certain areas improving memory, attention, or learning. Neurostimulation represents the inverse of mind over matter, using physical interventions to alter mental states and brain function. However, it also demonstrates the deep integration of mind and matter, showing that mental states are neural states that can be influenced from outside. Understanding neurostimulation reveals new possibilities for treating brain disorders and enhancing function, while also raising questions about the ethics of directly manipulating brain activity, about what it means to change the mind by changing the brain. The emerging field of psychedelic-assisted psychotherapy uses substances like psilocybin, MDMA, and ketamine combined with psychotherapy to treat mental health conditions. Research shows that psychedelic-assisted therapy can produce rapid, lasting improvements in depression, PTSD, anxiety, and addiction. The mechanisms involve acute changes in brain connectivity during the psychedelic experience, with increased communication between normally separate brain networks, combined with psychological insights and emotional breakthroughs facilitated by the altered state. The therapeutic effects appear to involve both the neuroplastic changes triggered by psychedelics and the psychological processing that occurs during and after the experience. Psychedelic therapy demonstrates that profound changes in consciousness can catalyze lasting changes in mental health, that temporarily altering brain chemistry can create windows of enhanced plasticity where therapeutic change becomes possible. Understanding psychedelic therapy reveals new possibilities for treating mental illness, while also highlighting the importance of setting, and psychological support in determining whether altered states lead to healing or harm. Precision medicine aims to tailor treatment to individual characteristics including genetics, biomarkers, and psychological factors. In the context of mind-body medicine, precision approaches might identify who will respond best to placebo effects, meditation, or other mind-body interventions based on brain imaging, genetic markers, or psychological profiles. This could allow more targeted, effective use of mind-body approaches, matching interventions to individuals most likely to benefit. Precision medicine recognizes that people vary in their responses to all treatments, including psychological ones, and that understanding this variability can improve outcomes. The challenge is developing the tools to predict individual responses and the wisdom to use these tools ethically. Understanding precision approaches to mind-body medicine suggests a future where interventions are personalized, where we understand not just what works on average, but what works for whom, allowing more effective, efficient use of mind-body approaches to enhance health. The study of exceptional individuals, including meditation masters, elite athletes, and people with extraordinary self-regulation abilities, reveals the outer limits of mind-body control. Tibetan monks can raise their body temperature enough to dry wet sheets in freezing conditions through meditation. Wim Hof can control his immune response and withstand extreme cold through breathing techniques and mental training. These exceptional abilities demonstrate that the boundaries of mind-body control are wider than commonly assumed, that with intensive training people can achieve levels of physiological control that seem impossible. Studying these individuals helps identify mechanisms and techniques that might be applicable more broadly, showing what's possible and how it's achieved. Understanding exceptional mind-body control reveals that human potential is greater than typically recognized, that the limits of what mind can control are not fixed but can be expanded through training, suggesting that abilities now considered extraordinary might become more accessible as we understand their mechanisms. The integration of artificial intelligence and machine learning into mind-body research offers new ways to understand complex relationships between psychological factors, brain activity, and health outcomes. AI can identify patterns in large datasets that humans might miss, predicting who will respond to which interventions, identifying biomarkers of mind-body states, and personalizing treatment approaches. Machine learning is being used to decode brain states from neural activity, predict treatment responses, and optimize intervention protocols. AI could help unlock the complexity of mind-body interactions, revealing relationships too subtle or complex for traditional analysis. However, AI also raises questions about interpretability and mechanism, as machine learning models may predict outcomes without explaining why. Understanding AI in mind-body research suggests both opportunities and challenges, the potential for new insights and better treatments, but also the risk of black box predictions that lack mechanistic understanding. The concept of embodied artificial intelligence suggests that future AI systems might benefit from having bodies, from being embedded in physical systems that interact with the world. This reflects the recognition that intelligence is not purely computational but embodied, that cognition emerges from the interaction of brain, body, and environment. Embodied AI might develop more human-like intelligence by experiencing the world through sensors and actuators, learning through physical interaction. This approach to AI is inspired by understanding of human cognition as embodied and situated, not abstract and disembodied. Understanding embodied AI reveals that the mind-body connection is not just a feature of biological systems, but a principle of intelligence itself, that thinking and acting are inseparable, that intelligence requires a body. This has implications for understanding human cognition, suggesting that our intelligence is fundamentally shaped by our embodiment, that mind cannot be fully understood apart from body. The ethical implications of mind-body interventions raise important questions about autonomy, authenticity, and enhancement. If we can use mental techniques to alter our biology, our emotions, our cognitive abilities, what are the limits? Should we enhance ourselves beyond normal function, using meditation or neurostimulation to become smarter, calmer, or more focused than nature intended? Who decides what counts as therapy versus enhancement? How do we ensure that mind-body techniques are used to promote well-being rather than to conform to social pressures or commercial interests? These questions become more pressing as mind-body techniques become more powerful and accessible. Understanding the ethics of mind-body interventions requires balancing respect for autonomy, the right to modify oneself, with concerns about coercion, inequality, and authenticity. It requires thinking carefully about what it means to be human, what we value, and what kind of future we want to create. The democratization of mind-body techniques through technology makes practices like meditation, biofeedback, and mental training more accessible than ever. Smartphone apps teach meditation, wearable devices provide biofeedback, online platforms offer mental training programs. This accessibility could allow more people to benefit from mind-body approaches, reducing health disparities and empowering individuals to take control of their health. However, it also raises concerns about quality, as not all apps and programs are evidence-based or effective. There's also risk of commercialization, with mind-body practices being packaged and sold in ways that distort their meaning or oversell their benefits. Understanding the democratization of mind-body techniques requires balancing enthusiasm for accessibility with critical evaluation of quality and ethics, ensuring that technology serves to genuinely empower people rather than to exploit them. The integration of mind-body approaches into public health could address population-level health challenges, including stress-related disease, mental health problems, and health disparities. Teaching stress management, meditation, and other mind-body skills in schools, workplaces, and communities could promote resilience and prevent illness. Addressing social determinants of health, poverty, inequality, discrimination, which create chronic stress and undermine mind-body health, is essential for population health. Public health approaches to mind-body health recognize that individual practices are important but insufficient. That creating healthy environments and addressing social factors is necessary for population well-being. Understanding mind-body health at the population level requires thinking beyond individual interventions to social and environmental factors that shape health, recognizing that mind-body connections operate not just within individuals but within communities and societies. The future of mind-body science lies in integration, bringing together insights from neuroscience, psychology, medicine, contemplative traditions, and technology to create a comprehensive understanding of how consciousness and biology interact. This integration requires bridging different levels of analysis, from molecules to minds to societies, and different ways of knowing, from scientific research to contemplative practice to lived experience. It requires humility about what we know and openness to what we don't, recognizing that consciousness and its relationship to matter remain deeply mysterious despite scientific progress. The goal is not just to understand mind-body connections, but to use this understanding to reduce suffering and enhance well-being, to help people live healthier, fuller lives. Understanding the future of mind-body science as integrative and applied suggests a vision where scientific knowledge, contemplative wisdom, and compassionate care come together to support human flourishing. The mystery of consciousness remains at the heart of mind-body science. The question of how subjective experience arises from physical processes in the brain. Despite tremendous progress in neuroscience, we still don't understand how neural activity becomes conscious experience, how the firing of neurons creates the felt quality of seeing red, feeling pain, or experiencing joy. This explanatory gap, the hard problem of consciousness, suggests that there may be fundamental aspects of mind that cannot be fully reduced to matter, that consciousness may be a basic feature of reality rather than just an emergent property of complex systems. Understanding this mystery requires both scientific investigation and philosophical reflection. Empirical research into the neural correlates of consciousness and conceptual analysis of what consciousness is and how it relates to the physical world. The mystery of consciousness reminds us that mind-body science, for all its progress, is still exploring fundamental questions about the nature of reality, mind, and the relationship between them, that the journey of understanding mind over matter is far from complete. And so we've journeyed through 100 facts about the profound connection between mind and matter, between consciousness and the physical world it inhabits and influences. We've seen how thoughts can change brain structure, how beliefs can alter body chemistry, how mental practices can influence the aging of cells. We've explored the placebo effect, neuroplasticity, meditation, visualization, and the countless ways that mind reaches into matter, shaping and being shaped in an endless dance of mutual influence. The boundary between mental and physical, once thought to be absolute, turns out to be permeable, with consciousness and biology in constant communication, each affecting the other in ways both subtle and profound. This understanding doesn't diminish the importance of physical medicine, but enriches it, showing that healing and health involve the whole person, mind, body, relationships, meaning, all working together. As you drift towards sleep, let these ideas settle gently into your awareness, the knowledge that your thoughts matter, that your mental states have real consequences, that you have more influence over your own biology than you might have imagined. The mind is not separate from the body, but intimately entangled with it, and this entanglement offers both responsibility and opportunity. The responsibility to care for your mental state as you would your physical health, and the opportunity to harness the power of consciousness to promote healing, growth, and well-being. Sleep well, knowing that even as you rest, your mind and body continue their quiet conversation, maintaining, repairing, and preparing for tomorrow.